For this question, we want to find the domain of the function f of x, y, and we want to find what values of x and y does this function exist. So here we have in the numerator a square root function, and for square root, everything needs to be greater than or equal to 0 under the square root. So we have y subtract x squared has to be greater than or equal to 0. And so for here, we can isolate and rearrange it just so we have it like y as a function of x. So that, because we know how y equals to x squared looks like, right? So we're going to say y is greater than or equal to x squared. So what I did there was I just moved this x squared to the other side by adding x squared to both sides. Okay, so that's one condition that we need to keep in mind when we're drawing our domain. The next one is we want to look at the denominator. This function only exists when the denominator does not equal to 0, or this function does not exist when the denominator is equal to 0. So we have 1 minus x squared is non-equal to 0. Okay, so we cannot equal to 0. And what we're going to do here is we're going to isolate and solve for x. So what we can do first is we can bring this to the other side. So we have 1 is not equal to x squared. So what I did there is I just add x squared to both sides. And then the next thing I'm going to do is I am going to take the square root of both sides to solve for x. And so when we take the square root, we always have to consider the positive and negative. So we have plus or minus 1 is not equal to x, right? I mean, we could also write 1 is not equal to plus or minus root x squared, right? So here we have square root of both sides. And then I'm going to just simplify. So I have 1 is not equal to plus or minus x. So I just simplified there. And then the next thing I want to write x is not equal to something. So I'm just isolating for x. So it's writing the same thing. X is not equal to plus or minus 1. So I'm bringing the plus or minus to the other side pretty much. And I'm swapping the sides because I'm putting the x on the other side. So here I'm just isolating for x. Okay, and so now we have our other condition. So x cannot be positive and negative 1, and y has to be greater than or equal to x squared. So we know how that parabola looks like. Let's start to sketch our domain. Okay, so we have 0, x, y, and then let's sketch our x squared. Draw this a little bit nicer. Okay, it's not to scale or anything. Let's just say this is 1, and this is negative 1, right? And we know, okay, x is not equal to negative 1, right? So it's not equal to negative 1. Actually, I'm going to draw a dotted line here like this. Okay, x is not equal to negative 1. So this is y equals to x squared. This is x equals to 1. This is x equals to negative 1. And we want to sketch the domain where this exists. So y has to be greater than this line. Actually, before I do that, I'm going to make the circles here and here because it cannot equal to 1. So y has to be greater than or equal to this, right? And it cannot equal to this line, x equals to negative 1. I'm going to erase this just so that it's not so confusing. Okay, I'm going to rewrite it in the red dots. So it cannot equal to this line. So that dotted line just means that it cannot equal to that. And it has to be greater than that. So pretty much it's just this shaded region here. Maybe I'll just write it a little bit neater. So it's this shaded region above that solid line does not equal to the dotted line and does not equal to those circles right there. And so here, this is the domain of f of x, y.